First of all, I'll show agenda for today, what I'm going to present. So, hello all, and nice to meet you all. Thank you for this opportunity to participate. This is a great honor for me and for Nokia. I'll tell you today my experience from developing AI assistants for shop floor operators and what decision-making support means from the edge data platform perspective. And I have also a short example what should be considered from the decision-making support perspective when working with building data assets. Shortly about myself, I'm here at close to Arctic Circle in Oulu, Finland. I've worked over 2 decades in various software roles, from developer to product manager in different companies and verticals. And before Nokia, I worked for Finnish oil refining company Neste, which is nowadays world's biggest renewable diesel producer and is leading, for example, waste and residue algae, liquefied plastic usage as raw materials. I worked as a product manager for OT digitalization, so data historians, OT data analytics, ML pipeline for AI products and AI operator assistant, which were using OPC UA interface and information modeling. Now I'm building application ecosystem with responsibility area to onboarding industrial IoT apps and hyperscaler capabilities and connectors to our on-prem edge computing platform, as well as looking for on-prem assets and connect and collect all data with industrial connectors to platform for aggregation, harmonization, analytics, and further directed to advanced Industry 4.0 use cases like AI and digital twins. So this is my environment, or our environment. Private wireless networks as main service with as a service principle, as well as devices, radios, and all related stuff. Then there is edge computing platform called Mission Critical Industrial Edge, where all the network management, other applications, as well as data processing on edge and on-prem environment happens with, for example, Litmus Edge Industrial IoT app. And whole system is managed from cloud, Nokia Digital Automation Cloud Portal, and as mentioned, as a service for customer. We can connect assets for private LTE 5G with many ways, as well as with Wi-Fi 6, but also use traditional LAN, so many kind of connectivity options are available. As I mentioned, I started from 2017. I was building operator AI assistant to process industries, and especially to shop floor environments. We built scenarios for machine learning and on-prem AI to improve process economy, but also to improve worker lifelong learning, shared situational awareness, and ways to increase active safety by recognizing possible anomalies, process behaviors, and mitigation procedures from simulation environment, and use those learnings to be applied to operator assisting. We also studied if machine learning and data-based models can be created to recognize potential deviations, disturbances, and even incidents in operations, and to help operators to prevent them. Part of the system were deep learning-based models and their inverses for control and action suggestions. And we kept control loop open to get human in the loop to improve learning and situational awareness. Like in planes which could fly automatically, but it's better to keep pilot aware of what's happening. For this, all the key functionalities must sit on-prem to prevent internet connectivity disturbances to disturb functionalities at critical moments. So, shop floor decision-making support by assisting workers for economy and safety by ML, AI, and digital twins can be a huge opportunity. But that's sets tough demands to data infrastructure to get real-time high-quality data for inferencing and simulations to make predictions which are needed for assistance and building what-if scenarios. That infra can also be used for lifelong worker training purposes at shop floor when they execute their daily activities, something that has increasing need in companies and which can be seen one of the key benefits of industrial metaverse. But that's hard to achieve if shop floor operational data lacks quality, structure, or semantics. For this, German Industry 4.0 and related parties has been actively working already years. So shop floor information has foundational role through value chain too, as many operations are dependent on previous or following production phases. That's why Edge is a starting point to whole supply chain in real-time decision-making support. From my experience from process industries, adoption of Industry 4.0 standards for operational data has been quite slow. With the AI boom, quick results have been wanted and data has been exported to the cloud at speed. At the same time, however, the existing OT standardization for digitalization and Industry 4.0, meaning OPC UA and its information models and company specifications, has been partially overlooked. The work done for standardization in the OT technology industry over a long period of 10 to 15 years threatens to remain unused because it has been faster to transfer data to cloud using tools familiar to IT people. And therefore, the advantages of OPC UA and the information modeling enabled by it have been forgotten by many promoters of digital transformation. It almost seems that the requirements for the speed of digital transformation in the very first steps threatens to make the next steps and use of AI and digital twins at scale ineffective, as the developed standards for semantic interoperability will not be utilized fast enough. And then, how does this seem from Edge point of view? But first, this is a slide which I present always nowadays when possible. It tells overall of whole industrial digitalization and how different areas are intertwined with each other. For example, digital thread cover asset lifelong life cycle from design to operations and whole life cycle with asset administration cell. Digital twin then can be constructed from many assets, processes, and features, and where operations phase information is best described with OPC UA. So my view on that is that the shop floor data is best collected with this standard, structured and semantic information included to the protocol. Of course, not always that's the case, depending on the business vertical, scale, and use cases, but I still recommend to seriously look twice for benefits of OPC UA in all OT data-related industrial applications. So for the future OT-IT integration, we should concentrate to information models instead of protocols. OT environment is mostly modeled for many verticals and purposes. Now those methods just have to be taken into use. OPC Foundation is continuing its activities with the REST initiative. The goal is to be able to offer a harmonized solution for the automation world that scales from the fields to the cloud and makes it easy to access the standardized information models of the OT world for applications such as asset administration cell, data spaces, and industrial metaverse. Those standard data models from OT just needs to be taken into action. That's my advice. And I strongly recommend reading that Jonathan Weiss's article on LinkedIn, which is, I have a link here. The information models matters, not protocols for future smart anything, smart manufacturing factories, smart energy, and so on. Here's my view on demand for on-prem industrial edge platform, which come from real-time decision-making support. Data needs to be connected, collected, aggregated, normalized, conditioned, and contextualized, preferably already at edge, to feed data ops or data hubs, but also to feed on-prem inferencing to reliably support shop floor AI and digital twins and predictions what smart manufacturing is looking for. To do that successfully, edge needs to support cloud services, IoT apps, and on-prem inferencing. All that sets a lot of expectations to openness and open standards. That's the direction to future too, as for example, industrial metaverse will rely on open standards and interoperable ecosystems. Sustainability, operational resilience, autonomy, interoperability, data sharing, and data sovereignty all benefits from open standards and semantic interoperability and push limits of production economy, safety, and productivity. Then I would like to drive through a small example of how industrial IoT apps like the Litmus Edge contributes to that vision. Decision-making support really starts from Edge with flexible open platform for data. Here you can see how Litmus Edge enables industrial IoT use cases. Let's look at a situation from one vertical perspective. I added operator AI assistant and digital twins for shop floor decision-making support here. Then just grouping assets and machines under greenfield and brownfield. Let's now look those which potentially benefit from shop floor inferencing and predictions for decision-making. From enterprise and data infrastructure perspective, would be easier to arrange inferencing as a service for all apps that need predictions to make maintenance and scalability of data infrastructure better. Then again, just change the visual elements for next steps a bit. And so we are getting the elements that enable the shop floor decision making and can be connected also to existing enterprise level applications, which is supported by structured data from OT to feed industrial data ops, data hub, and MLOps practices to make orchestration of many models, whether first principles or data-based, efficient, and maintenance of overall system easier. And that's how we get to this overall picture, which presents how we see Edge meaning for enterprise operations. So simplify industrial IoT and operational AI complexity with structured data starting from Edge. And industrial IoT applications has the key role on that scenario. As a takeaway, I would like to say that structured data, for example, OPC UA with information models and company specifications, helps to achieve those promises. We have heard a lot like scalable, transferable, flexible and resilient, maintainable digital operational solution. And it all starts from on-prem Edge. Thank you.